Hello everyone, so today we are going to solve a very interesting problem number 239, sliding window maximum. And the problem says you are given an array of integer nums. There is a window of size k which is moving from very left of the array to the very right. You can only see the k numbers in the window. Each time the sliding window moves right by one position, return the maximum window size. Okay, so just by looking at the problem, the very intuitive approach that comes to my mind is that we have this array like this: 1 3 minus 1 minus 3 5 3 6 7, and we have to maintain the size of window 3, right? So we have been given, like, we have to maintain this k is equal to 3, and as we are traversing in the as we are moving this window from left to right, we want to grab the maximum of these windows value, right? So if I'm in this, so one approach that I think in everybody's mind comes is like, I can just iterate the traverse the array, and we can keep two pointers, one at I equal to r and the another at r is equals to I plus k, and we'll grab the maximum value in this window, grab maximum value, store it from L to R, store it and return the answer, right? So but I tried with that approach, and that approach is giving time limit exceed time limit, so I have to discard this approach of two pointers sliding window. So I came up with another approach. So that approach is which I'm going to discuss with you. So what we can do is we can build a max heap, and as we are maintaining the max heap, what we'll do is we'll keep the maximum element. So because it's a property of max heap that the top element would always be present at the highest element will always be present at the top root of the heap. So as we are building the heap, we'll grab out the maximum element from the top and we'll return the answer list that will create using this top element. So if I start filling up the max heap with the arrays values, so this is how it would look like. So this is 5 3 6 and 7, and we have the indexes value of this 0 1 2 3 4 5 6 7, right? So we'll first fill with the k items, k minus 1 items. So where the very first thing I would do is, like, we need array of size k, so I will fill the two items in the heap, and as we are going to build the heap, we'll fill more. So this is how it would look. So first we'll start filling -1 comma 0, and then we'll fill -3 comma 1. So now it's the property of max heap that the child must be bigger than the parents, so these will to switch and the values will become -3 comma 1 and -1 comma 0. And now we'll add another element in the window, that is -1 at position 2, and now we'll see that our maximum value of this window is present at the top, so we'll grab this into an answer list, that this is the value of 3 that we want into our list. So we'll append that. Now we'll again go further and build our tree more. So this is another 2 child nodes, so that would be coming from the next values. So the next values -3 at index position 3, so it would be 3 comma 3, and this is greater than the parent, so no need to change the heap. And the next value come is -5. So in this window of this -3, 1, 2 and 3, I want to grab the maximum value, so that I can do by just looking in the priority queue up till the I have exhausted all my indexes. So in this region I will have the maximum value as 3 again, so that I will again append into my answer list that I have just built. So that would be -3 again. So similarly, now we'll go back and maintain our next. So this is -5 comma 4, and we'll build this again. So this will change its value with the uh, next up. It says parent node, so this would become -1 comma 0, and this would become -5 comma 4, and this again would change its value with the top, because it is the property of max heap that a child node will be less than the parent node. So now we'll grab this 5 comma 4 into our list that we have built. So this is -3 comma the new value that was there 3, and the next value that is 5. So we'll do these operation continuously, and at the end we'll get the answer list in the way that we want. So this would again change to 5, the next value. So the next value is in the heap, the next value would be 6, 5, and then it would be 6 and 7. So I hope you got the idea, and now let's get into writing the code. And here is how we can write this approach. So first thing, we are building the heap till k minus 1 elements. So we need one priority queue to build our heap, and we'll go in the range from 0 to k minus 1. We'll push this into our heap. So we want the value first, and we are building the max heap, so we need the negative of that value and their indices to trace back. So this is our initial heap of size k minus 1. Now we'll start again from k minus 1 to n, which is the length of the total nums. N is the length of total array that we have, and we need one answer list to capture an answer, and we'll start from the remaining k minus 1 to n elements, and we'll start pushing them into our heap one by one. So this would be as nums of I comma I, and as we are going to push, we want to check like whether in my priority queue the index that I'm maintaining, is it within the uh, three positions, so from I till I minus 1, and if it is within this window I want to pop out these elements from the priority queue and append this into my answer list that I have built. So in the building, when we need the values rather than indexes, so we'll do that, and in the end we'll return our answer list that we just have created. So, and there are no constraint like the nums could not be empty, so the window will there will always be the element of window k. So now let's run our code and see how it performs. Okay, so I have to add so since we are taking the values directly, we have to add a negative sign into that, so that to make them a positive back again. Now, okay, so now let's run for example test cases. I believe it has been already done, and now let's submit our code and see how it performs. Okay, so it has been accepted. So I don't know why Leetcode has made this specifically hard, because the initial approaches were also good, and but I think they want to more focus on this approach, because it says that you have to solve this problem using the heap priority queue, and it is not accepting the sliding window answer. So this is my approach using heap. So the time complexity for this would be O of n log n, because building the heap would take log n time, and we are iterating through all the elements in the list. So, and so that's why time complexity is n log n, and the space complexity is also O of n, because we are maintaining the uh, array list of size n, and if we can ignore that, then the space complexity would reduce to O of log n, that is the size of building the heap that we created. So this would be the sliding window maximum, and I hope you are liking my solutions and I'm helping you out in your interview journey. Please like and subscribe to this channel, that motivates me to keep making such more awesome content for you guys. Thank you and have a good day. I will see you tomorrow.